Welcome back to B-Spice. In OT cybersecurity, in this session, we'll continue with defense in-depth architecture capabilities, and this is the third session on this topic. In this session, we'll talk about the very important aspect, Zero Trust Architecture, ZTA. Just remember this matrix, friends. See, it's all about zero trust. It's all about zero trust in the sense, identity access management, never trust, always verify, and least privilege, and micro segmentation and continuous monitoring. This is all about the zero trust architecture. Just remember all these words. This is what we are going to talk in this session. Okay, as you know, in the previous sessions, we talked about the same topic, defense architecture capabilities, wherein we talked on security management, which focuses on the layer one. Then we have layer two physical security also discussed, and this is the layer three network security. In fact, in the network security, we have already uploaded two videos. So this is the third one on this subject. Okay, if you're interested, you can watch. And of course, we are not going to stop with this. We are going to continue with layer 4 hardware security and layer 5 software security in the next and subsequent sessions. Right, let's get on with the layer 3 network security, and which we'll talk about the zero trust architecture. Zero trust architecture, yes, ZETA, is a cybersecurity framework that assumes no user, device, or system inside or outside the network should be trusted by default. Every access request must be continuously verified before granting permission. So that is the point. Zero trust architecture. Yeah, ZEA is a cybersecurity paradigm, meaning a framework that focuses on protecting resources. Resources in the sense information, services, data based on the premise that authorization decisions are made closer to the resource being requested and are continuously evaluated rather than implicitly granted. So that is the point. You got it, friends? Resources are being requested or continuously evaluated rather, implicitly granted. Just like that, we don't give, grant a permission for this. So that is the all about zero trust architecture. So conventional network security focuses on segmentation and perimeter defenses, as you know. So once inside the perimeter, users are typically considered trusted and often given broad access to accessible resources, isn't it? So that's not the way. It should not do the way actually. Yeah, that's the point. As a result, boundary protection devices between zones do not mitigate lateral movements within the zone. That's the point. Okay. This is all about the zero trust architecture. Let's continue. Additionally, with growing prevalence of distributed computing, wireless and cellular communication, and cloud and hybrid cloud environment, traditional network parameters and boundaries are becoming less defined, isn't it? I hope you agree with the statement. I repeat again, friends. Additionally, with growing prevalence of distributed computing, wireless, very important, and cellular communication, and cloud and hybrid cloud, traditional network perimeters and boundaries are becoming less defined. So, for this situation, organization might consider incorporating the principles of zero trust into their architecture. So, that is the point. Some challenges to implement ZTA include organization may not find a suitable single solution for ZTA and may instead need to integrate several technologies with varying maturity levels to support the environment. Yes, of course, we have to do that. Then, implementing zero trust principles into an existing environment may require more investments in time, resources, and technical ability, isn't it? Yes. So, this is a challenge about the implementing the zero trust architecture. Okay. Now let's go into the, some components, friends, some components, OT components like PLC, controllers, HMI may not support the technologies or protocols required to fully integrated with the ZTA implementation. So as a result, a ZTA implementation might not be practical for some devices. So what we have to do? Instead, organization should consider applying a ZTA to compatible devices, such as those typically found at the functionality higher levels of OT architecture, like the Purdue modules, which we had talked earlier on level 3, 4, 5, and OT DMC. So we can do that ZTA on this particular Purdue model level 3, 4, 5, and OT DMC. So that is the point. Okay, right. So now let's talk about the core principles of zero trust architecture. What is the principle behind this? Zero trust flips the traditional security model on its head. Instead of trusting users inside the network parameter, ZTA treats every access attempt as potentially hostile. That's the point. So never trust, always verify. Every user and device is authenticated and authorized before accessing resources, even if they are already inside the network. That's the point. So never trust, always verify. Then least privilege access. Users and devices are granted only the minimum access needed to perform their task, reducing the risk of lateral movement during the breach. So least privilege access. Then micro segmentation. Network resources are divided into smaller zones to limit the access and contain threats. That's about the micro segmentation. Then assume breach. ZDA operates under the assumption that breaches are inevitable, so it focuses on minimizing the damage and detecting threats early. So assume breach. So these are core principles of zero trust architecture. Of course, the last but not the least, continuous monitoring. Access decisions are based on real-time data like user identity, device health, location, and behavior. So we need to have a continuous monitoring over this. So these are the core principles which I highlighted in the first slide. Okay. That's about the core principles. Now, why zero trust architecture matters today? Yes, with the rise of remote work, cloud computing, mobile devices, traditional parameter based security is no longer sufficient, isn't it? I hope you agree with this statement. Yes. So, how this zero trust, address this? Yes, it addressed by supporting secure access from anywhere, reducing the attack surface, enhancing the regulatory compliance, strengthening the protection against inside threats and advanced cyber attacks. So this is about the, zero trust architecture. Why zero trust architecture matters today. That's the point. Then now, the last use cases and implementation. ZDA is widely used across industries such as finance, health, care, energy, all these. So what all the components include? Multi-factor authentication. So what's a multi-factor? Multi-factor authentication is a security method that requires the users to verify their identity using two or more distinct form of credentials. So they significantly reduce the risk of unauthorized access compared to relying on passwords alone. So that is the point. Okay, you got it, friends? Right. Then we'll go into the second item. Identity and Access Management, IAM. What is this identity and access management? It's a framework of policies and technologies that ensure that the right individuals and system have appropriate access to the resources at the right time and for the right reason. So it's a cornerstone of modern cybersecurity and digital infrastructure. That's about the IAM. Then we have a endpoint detection and response, EDR. What is this EDR? EDR is a cybersecurity solution that continuously monitors and analyzes the endpoint devices. Endpoint devices in the sense, laptops, desktops, mobile phones, IoT systems, all. So it's a cybersecurity solution that continuously monitors and analyzes the endpoint devices to detect, investigate, and respond to threats like malware and ransomware. It provides a real-time visibility and automated responses to protect the organization from advanced cyber attacks. So that's about the endpoint detection. Then we have a secure access service edge, SASE. We call it as SASE. Okay. So what is SASE? So SASE is, nothing but, a cloud native architecture that merges networking and security functions into a unified service, enabling secure and efficient access to resources from any location. So it's a design for modern distributed workforce and cloud first environment. So these are all the components. So implementing ZTA, zero trust architecture, is a shift in mindset. It requires a shift in mindset, mentality, right? Robust policy enforcement, and integration across IT infrastructure. Yes. So that's all I have for this ZTA, Zero Trust Architecture. Thanks for your support and continue this same topic, Defense in Depth Architecture, in session 4 of this topic, wherein we'll talk about hardware security and software security. Thanks again. Take care. Bye-bye.